Hi everybody. Today our subject is trigonometric functions. Yeah, trigonometric functions. First of all, we have to know that this one is initial ray and this one is terminal ray, and we can measure this angle. So this is positive measure. Yeah, and on the opposite side, if we have a terminal array like that, and our measure is that, and initial ray is that, so this one is negative measure. So we describe angles positive by counterclockwise rotation. I mean this one. Counterclockwise rotation is this one. And this is one. This one is clockwise. Is negative measure, and positive measure is counterclockwise rotation. And we can also measure such as like that. This may be, say, P is equal to 180 degree, and say this one is 9p over 4, and also this may be easily find. Say this one is p over 2, and this one is p, and we have also p here, and of course this one is 2p. So if we want to measure this one, this is 3p. Yeah, like that. Now we are starting with trigonometric functions. Second one now. We have to know degrees and radians. What I mean, degrees and radians. We have this triangle, and now here we have degrees, and we have to have a and a square root 2. This may be also like that. If we say a is equal to 1, this is square root 2. And here we have degrees here, yeah, 45, 90, and like that. And on the other side, no, this is not that I want. No. Okay, like that. Now this one is P over 2, and this one is P over 4, and this one is P over 4. You know P is equal to 180, so P over 2 is equal to 90, and P over 4 is equal to 45 degree. And again, if we have A here, and A square root 2, and same things also from here, 1, and square root 2. Yeah, this is the name that we give degrees and radians. Yeah, P type and degree type here. And now next one. Trigonometric ratios of an acute angle. What I mean this one. Let's say this one is our angle alpha, and here is adjacent, and here is opposite, and hypotenuse. I think here's like that. Hypotenuse. Yeah, like that. If you want to find the ratios, trigonometric ratios, such as sinus alpha is equal to, opposite over hypotenuse, and cosinus alpha is equal to adjacent over hypotenuse, and by sinus we can find cosecant alpha is hypotenuse over opposite, and by cosinus alpha we have secant alpha, and this is this one, yeah, and like that. Second is adjacent or opposite, and tangent alpha is equal to opposite over adjacent, and cotangent alpha is equal to adjacent over opposite. Yeah. Finally, we can also say these ratios. We can also give these ratios. Tangent alpha is equal to sine alpha over cosine alpha, and second alpha is equal to 1 over cosinus alpha, and this is not, sorry. By the way, I think I made a mistake here. I think this one is not true. So true one is hypotenuse or adjacent, and this one is equal to 1 over sine alpha. Yeah, we have to know this one. We have to know these ones. And now let's say we have like that 30 degree and 60 degree here, and we have to know that 1 is here and square root 3 is here and 2 is here because 1 square and square root 2 square is equal to 2 square here. And we also have like that another triangle 1 and square root 2, and here 45 degree and 45 degree. It's easily seen that this is because 1 square plus 1 square is equal to square root 2 square. And now we know that sine 30 degree is equal to, sine p over 6. So it is 1 over 2. How can we know that? We know that sine is equal to opposite over hypotenuse. So we find this one, the opposite of the 30, and we find this 2 in the hypotenuse. So we can easily find the numbers. Also, sine 60 degree is equal to sine p over 3. So it's equal to square root 3 over 2. This is because, again, opposite of 60 degree is equal to square root 3. This is opposite. And hypotenuse again is 2. So it is square root 3 over 2. Yeah. And next one, let's find cosinus 30 degree. It's again like sinus 60 degree because don't see here, and it is square root 3 over 2 because adjacent of 30 here, adjacent for 30 degree, adjacent over hypotenuse. So adjacent is square root 3 and hypotenuse is 2. So it is square root 3 over 2. And if you want to find tangent 30 degree, it is sinus 30 over cosinus 30. So since 30 is 1 over 2 and cosinus 30 is square root 3 over 2. And if we did this calculations, we could easily find that this one. We could easily find that. So this one and 1 over square root 3 is tangent 30. And we can find then tangent 60 degree also from here. Sinus 60 over cosinus 60. And sinus 60 is square root 3 over 2. And cosinus 60 is 1 over 2. So we can also write cosinus 60 here. It is adjacent over hypotenuse. Adjacent of 60 degree is here. It is 1. And hypotenuse is 2. It's 1 over 2. You see here's one stand from here. So for the calculations, 2 over 1 tangent 60 degree is equal to square root 3. We can easily find that. And next one, we can also write here, I think. We can also write here. Yeah. Sinus 45 degree is equal to, as radian P over 4 is equal to, let's say this degree, and sinus means opposite over hypotenuse. So it is opposite one of this 45 degrees 1, and hypotenuse is square root 2. And also cosinus 45 degree is also the same as sinus 45 degree. I know this is adjacent over hypotenuse. So one of the 45 degree of adjacent is, say, 1 over square root 2. So this is okay for cosinus 45. And if you want to find the tangent 45 and cotangent 45, you know that they are sinus 45 over cosinus 45. So it is 1, and they are saying 1 over square root 2 and 1 over square root 2. We can also write these ones. 1 over square root 2, 1 over square root 2, and it is 1. Also, cotangent 45 is equal to 1. Yeah. And finally, we can also write secant 45 and cosecant 45. You know that secant 45 is 1 over cosinus. So it is easily understandable that it is square root 2 from here. And cosecant 45 degree is equal to also square root 2 from 1 over sinus 45 degree. You have to memorize all these things, of course, by calculating maybe from these triangles. Now, not that. Sinus P over 2, I mean sinus 90 degree is equal to 1, and cosinus P over 2, I mean cosinus 90 degree is equal to 0. So tangent P over 2, it is, sinus over cosinus, so it is not exist. Okay. And also we have sinus minus 90 is equal to minus 1, and cosinus minus 90 is equal to 0. So tangent minus P over 2 is equal to, 90, also not exist. We can also find the others. What are the others? Cotangent P over 2. It's easily understandable that it is 0 over 1 and 0, and cotangent minus P over 2 is equal to 0 over minus 1. It is again 0. And we can remember all these things. From here, I think. From here. And if you want, you can use this table to remember or to summarize or to understand all things. And by the way, also we have something easier to understand. A, S, T, and C. A, S, T, and C. What I mean? All positive here, all positive. Here only sinus positive. Here only tangent positive, and here only cosinus positive. So if you find these things in your memory, if you somehow memorize these things, you can easily understand where is the positive ones, such as you can example. Let's give an example here. We have 120 positive of measure, here. It's counterclockwise. So this degree is equal to sinus 180 minus 120. This is sinus this one. And cosinus 120 means cosinus 120. This is cosinus minus 60. What's that? From also here, this one is the answer of this one, and we also can know from the triangles. How can we know? We know that these are the numbers. So if you want to find sinus 60 degree, you said that it is opposite of 60 over hypotenuse. Opposite of 60 is square root 3, and hypotenuse is 2. It is like that. Cosinus 60 degree is adjacent over hypotenuse. Adjacent of 60 is 1, and hypotenuse is again 2, 1 over 2. So the answer is minus 1 over 2, and here is square root 3 over 2. I won't give this table, so you have to know this triangle and also this triangle for the exam. Not this one. This one. 45, 1, 1, square root 2. You also have this one and this one. So you can easily find these numbers also by knowing this one. All positive, sinus positive, A, S, T, C. Yeah, this is important. Next one. And we can also use this thing, I think. Yeah. Another example. If tangent alpha is equal to 3 over 2, and we know that alpha is between 0 and p over 2. Yeah. The question is, find the 5 other trigonometric functions. Now, for doing this one, we have to draw again a triangle. We have to draw a triangle, and let's say this is our angle, and on the opposite part, you know that tangent means opposite over adjacent. So opposite of alpha is 3 and adjacent of alpha is 2, and we have to find this x. So finding the x, we can use this inequality of course, inequality. 3 squared plus 2 squared is equal to x squared. So here 9 and 13, I think, and x is equal to square root 13. Now, finally, we can write sinus, cosinus, secant, and cosecant, cotangent, of course, also. Sinus means, you know, opposite over hypotenuse. So it is 3 over square root 13. Cosinus means adjacent over hypotenuse. So it is 2 over square root 13. And cotangent means adjacent over opposite. So it is 3 over 2. And final two things is secant alpha is equal to 1 over cosinus alpha. So it is square root 13 over 2. And cosecant alpha is equal to 1 over sin alpha is equal to square root 13 over 3. These are the answer of the question. And next one. And here, note that if we add 2p, if we add 2p to the measure, I mean alpha measure, nothing will change. Nothing will change. What I mean by nothing will change, this is cosinus alpha plus 2p is equal to cosinus alpha again, and sinus alpha plus 2p, again sinus alpha. Also, for the other ones, they are same, secant and cosecant, they are same, because if we go on counterclockwise 2p, we will be the same position of the first position. We will be at the same position here. Let's say we are here and we are going on the counterclockwise position. You see, when we measure 2p, we come back at the original position. So the answers are same. Now this is the end of this week. We will continue with trigonometric functions. Trigonometric functions doesn't finish here. So see you next week. Bye bye.